Bode plot gain and phase measurements are often used to characterize the frequency response of a broad range of devices and circuits, including analog filters, as well as power supply feedback networks. They are also performed extensively in university teaching labs to help teach engineering students about the concepts of frequency-dependent variables, including the impedance of inductors and capacitors. Hi, I'm Johnny Hancock, Product Manager for Keysight's InfiniVision X-Series oscilloscopes. Let's get started by showing how to create a Bode plot of a bandpass filter the old traditional way using an oscilloscope and an external function generator. So I have a bandpass filter here. This is actually a training board that ships with this particular product, the 1000 series oscilloscope. And I have my external generator connected to the input. I'm probing channel 1 on the VN pin, channel 2 on the VOut pin of this filter. And I'm going to go through the measurement technique that, say, a student in the university would do the way I did it 45 years ago. They're doing it the same today. Now, if you're in industry, maybe your company can afford to buy a network analyzer or a frequency response analyzer, but in the university environment, they typically use just oscilloscopes and an external generator. So I've got the scope set up at 100 hertz, 1 volt peak to peak. I've got, or the generator, I've got the scope set up and it's measuring channel 1 V in, channel 2 V out. I'm going to make measurements at 100 hertz, 200 hertz, 500 hertz, 1 kilohertz. I'm going to step all the way up to 10 megahertz. So it's going to be a lot of measurements. So the first measurement here, it measures V in, measures 0.99 volts. I'll write that down. V out measures about 28, 29 millivolts. And the phase measures 88 degrees. Now, compute the gain, 20 log V out over V in. So I got 29 E3 minus enter 0.99 divided by log 20 times minus 30.7 dB. This is my 15C engineering calculator app on my mobile phone. So now I'm going to change the frequency to 200 hertz and repeat. That was a lot of work. So here's all the data I took. Here's my plot. It's not all that accurate. In just a minute, I'll show you how it can be done much quicker with the InfiniVision oscilloscope. But first, I want to have a little talk about Bode. The last time I did a video on Bode plots, I got lots of comments down there in the comments section calling me an idiot, saying I don't know how to pronounce Bode. They say it is with a long O and a silent E. I'm here to tell you, technically, Bode plots are named after Dr. Hendrik Wade Bode. It's a Dutch name, and the Dutch pronunciation is Bode. His family preferred the Dutch pronunciation. His colleagues, including Claude Shannon and Harry Nyquist at Bell Labs, they called him Bode. All my professors called it a Bode plot, so it's a Bode plot. Now, let's do it a much more efficient way. So now I'm going to plug in my bandpass filter directly into the generator output of the oscilloscope, go into the Analyze menu, and select Frequency Response Analysis, which means Bode plot. And I'm going to set it up to start sweeping at 100 hertz, stop at 10 megahertz like we did manually. And let's increase my amplitude so that we're doing it exactly like we did with this scope. And just say go. And so it automatically scales the signal. It measures using the frequency domain. It measures the magnitude of both V in and V out, begins plotting it. The blue plot that's creeping across screen here, that's the gain plot. The orange or the reddish looking plot is the phase plot. It started up around 90 degrees. The gain plot started around minus 30, which is what I determined manually. And it goes up to about 0 dB. And there you can see it then trailing off. Exactly the characteristics that you would see from a bandpass filter. At this point, I could make measurements with the markers. And over here, it tells me exactly what the gain, phase, and frequency is at any point. I could export the data and analyze it offline if I like. Now, that was a lot faster, a lot easier, and a whole lot more accurate. Automatic Bode plot measurements are standard on the 1000 X-series oscilloscopes that have the built-in generator, and it is an option on the 3000T, 4000, and 6000 X-series oscilloscopes. If you think you might have learned something in this short video to make you more proficient in performing oscilloscope measurements, I invite you to view our other InfiniVision oscilloscope measurement tips videos. To learn more about Keysight's InfiniVision X-series oscilloscopes, go to the URL listed on your screen or contact one of Keysight's authorized distributors. Thanks, and Semper Fi.